The Liebherr LRB piling and drilling rig can not only be equipped with a rotary head, a press or hydraulic hammer, but also with a vibrator or a ring vibrator. Vibrators can be used to drive all sheet piles, steel beams, combined profiles, as well as steel tubes with a corresponding clamp system. Ring vibrators can be used to drive tubes with varying diameters or H-beams with excess length. The LRB, the Universal Piling and Drilling Rig from Liebherr. For the construction of the new central office for Aldi Swiss AG in Domdidier, a 425-meter long and 200-meter wide building complex was created. The building site is located in a sensitive area, not only from a geotechnical point of view, but also with regard to soil mechanics. The foundation soil consists of young post-glacial sediments. Because of these difficult soil conditions, the foundation soil expert recommended to carry out extensive test loadings. The test loadings of prefabricated driven piles and vibrated cast-in-place piles brought a clear result. Under working load, the vibro pile shows only a minimum settlement, and even under maximum load, it does not display any sign of reaching the breaking load. For pile installation, ring vibrators are used on Liebherr carrier machines. The compact transport dimensions and the quick and easy assembly of the LRB machines allows for their flexible application. Thanks to the hydraulically adjustable leader, the vibration pipe can be perpendicularly aligned in all directions, even during the installation process. The ring vibrator type 32 VMR is able to install vibrating elements with a maximum diameter of 610 millimeters. A pipe of 356 millimeters diameter is used on this job site. In order to fit it into the ring vibrator, the service team must first mount clamping jaws. For penetration of the sand layers, jetting-assisted vibrating with low-pressure jetting is applied as an installation aid. This is a successful method for reducing toe and shaft resistance. For this method, the vibration pipe is fitted with two 1-inch jet pipes opposite each other, whose outlets are closed with ball valves. To create these piles, a single-wall steel pipe which is closed with a base plate is vibrated into the ground. The base plate is fitted with a seal to prevent intrusion of groundwater. The sealing plate, which seals under pressure, is not relieved during the vibration process, so that destruction or reduced water tightness cannot occur. With the prevailing geological conditions on the building site, water jetting is turned off after penetration of the sand layers, and the areas beneath are vibrated without water jetting. In order to prevent the loss of large amounts of concrete and to ensure the pile cross-section, the reinforcement cage is inserted into a geotextile stocking. For ensuring centered placement of the two-part reinforcement cage, it is fitted with spacers. The geotextile bag is folded back and tied at its upper end. This ensures that during subsequent filling of the bag, the concrete is prevented from flowing down outside of the bag. Thanks to the technique of installing a steel pipe in one piece and also extracting it again in one piece by vibrating, all of the pile concrete can be poured into the pipe in a single process. Thanks to the water tightness, no contractor pipe is required. When the pipe is extracted with the ring vibrator, the base plate remains in the ground and the concrete is compacted due to the vibration. As the ring vibrator is repositioned for extracting the second part of the extremely long pipe, the jet hoses are already being mounted again for the next cycle. The pipe used has a length of 35 meters. Thanks to the high capacity of the LRB carrier, the vibrating pipe may project up to 8 meters beyond the top end of the leader. After the pile is completely hardened, the pile head is freed from excess concrete and prepared for the next production steps. In addition to the normal foundation piles, energy piles were also produced on the Dôme Didier job site. In this case, the reinforcement cage is inserted in one piece. The metal network is fitted with a hose which is checked for tightness. This hose is intended for the subsequent circulation of cold or hot water. The system utilizes the near-surface geothermal potential for heating or cooling. After mounting of the hose, the reinforcement is lifted into a transport frame and fixed to an electric winch. This prevents the construction from bending during lifting. After the steel pipe has been brought down to its final depth by the ring vibrator and the workers have introduced the geotextile bag, the reinforcement cage is lowered into the pipe. Thanks to the combination of ring vibrator, LRB carrier, and BVV jetting assisted vibrating, one cycle does not take much more than 20 minutes. In order to ensure the best possible quality of the foundation piles, extra controls were carried out in addition to the production protocols required according to DIN. A minimum of 10% of the piles were submitted to a low-strain pile integrity test. For this purpose, an acceleration sensor is fixed to the pile head and a shock wave is created with the blow of a hammer. This wave goes down the pile shaft as a compressional wave, and is reflected at inhomogeneities or at the pile toe. On this job site, 2 vibrating units were applied for 5 months and 1 more vibrating unit for 3 months. Every machine produced an average of 2 piles with a length of 35 meters each per hour. Thus, on this job site, 7,500 piles with an overall length of 270,000 meters were produced in only 5 months. The production of the foundation piles has proved that the combination of an optimum application method with powerful and modern machinery does not only lead to high productivity, but also fulfills high quality requirements.